Is that coming up? Okay, so we're going to be talking about behavior-driven development today, and just a heads up of what we've got coming. Next week, we've got Adam Zyman coming. He's talking about progressive delivery, a book he wrote. This is a lot of the people I've gained coming in and talking have written books for IT Press or IT Revolution, which did the Unicorn, and I think it was the start of that was the Phoenix Project. So anyway, they tend to vet people very well for writing books, and so have some interesting people coming in. So anyway, Adam's coming in next week, and then after that, I'm going to talk about effective remote presentations. And just to give you a teaser, the way that I talk about effective remote presentations is tell you all the things I've done that have gone horribly wrong, blowing my nose, accidentally consuming way too much caffeine. Anyway, this will be an interesting talk just to look at different ways to give presentations online and things that work well and a lot of things that work poorly that you can laugh with or at me how they've gone. And then after that, we've got Johanna coming talking about fake agile is not the norm, how to install agility, not agile practices. This is an area that I think is very key. A lot of us are experiencing this where in areas where agile has become a thing that you say you do without necessarily practicing it. And so she's going to be talking about that, which I'm really looking forward to that talk.
Why is this not working?
Can you not hear me, Randy? Maybe you got it. Okay, so today we're going to talk about behavior-driven development. And this is the million-dollar idea. Teams that I've seen, like imagine you're the team you work with, and would you, is there any, like how likely do you think it would be for your teams to say, the way we are working is awesome, I never want to work in any other way. This is the way, this is like the ideal way to work. And a lot of us probably are working in areas where that is not what our developers would say. I have seen teams that say that, and it's when they're doing this. So we're going to talk about that. So to talk about test-driven or behavior-driven development, first let's look just kind of high level, and let me kind of give you an idea of where we're going with this. I don't have a lot of interaction in this because it's I always run out of time, so I took some of the quizzes and stuff out. My goal is to give you a high-level idea of how this works and the value that you could get from it, not necessarily all the technical details. I want to give you enough that you can understand the value, but not necessarily, we're not going to spend a whole bunch of time on code. Okay, so to understand behavior-driven development, we need to understand what test-driven development is, because oftentimes these things get thrown around and confused, and there is some overlap where people say, well, should we do one or the other? And they're very different things. So the test-driven development process looks something like this. We ask ourselves, what is the smallest piece of functionality that would be closer to a working system? So how would I prove that the system worked? Like, what's the smallest thing that would be a step forward? Something that, and usually what we're trying to think in terms of is something that the user would say, this makes my life better. I am happy that you did whatever this is, because it's very easy for developers, and I, talking to myself here too, to do lots and lots of things that do not make the user's life any better in any way that they can understand. They may be great things to do, but we're looking for the smallest piece of functionality that would be closer to a working system. Then we ask, how would we test that this functionality exists? Whatever this piece of thing is that works. And then we do this. So we write a simple test for it. We watch it fail. We write code. The test passes. Then we refactor. And this refactor, this is really important. This basically says, is what we actually did to make this test pass sane? If we did something really crazy and we got it to work, we don't just stop there. We say, okay, we got it to work. Now let's try to tweak it to where we're happy with what it does. I was working with a team the other day, and we got something to work, and it worked in ways that we did not expect. But had we left it there, we would have been in a really bad situation because no one else would have had any idea of what it was if they came back and looked at it. So that's where you refactor to make sure this is something you want to live with for the rest of your life, for the rest of your time in the company. Then you move on to the next simple test. So that's what it looks like if you're doing test-driven development. And this is driven, I think I may have misspoke a little bit. This is driven very much by how the developer sees a functionality. Not necessarily what the user would see. Like I said, I misspoke. This is how the developer is thinking of incremental progress. And it looks something, if you've seen anything like this, and don't worry about the details, but we've got a service that adds numbers together, and we say that we expect 1 when we add the numbers 1 and 0 together. And we're trying some different things, and we're trying some negative numbers. And that's what test-driven development will look like, is something like that. And like I said, don't worry too much about the details of that. And we can also do test-driven development at a different level. This one is dealing with things at the controller level. It's not super important for the context of this talk. So with that in mind, what test-driven development is, let's look at behavior-driven development. And I'm going to be showing things using a tool called Cucumber, an open source tool that's fairly common. There are other ones. The approach is what's interesting. You can even do this without tools if you want. So in this case, we ask ourselves, what is the smallest usable feature that would be closer to a working system? So notice we've switched from saying, as a developer, what do I see as incremental progress? And we're now asking ourselves, what's a usable feature? Not just a function, but a feature that would be closer to a working system. In the example I just gave, adding two numbers together just in the raw way of adding two numbers together might not even be something that a user could experience at all. So it wouldn't be seen as a usable feature. So now we're thinking more from the user's standpoint and asking ourselves, what would they think would be a step closer to a working system? So then we do something like this. We define the desired behavior as an example. And this may sound complex, but no, it's very simple. It's like when I come in and I try to do this, then this is what I can do. And in a lot of the research I've seen around teaching people how to write code, this is a key thing. Just saying, start with an example of what you want the code to do and then write code that passes that. And it makes this is probably what everybody assumes developers do anyway, but this often is not how developers actually approach their work. So we define a desired behavior as an example. We make that example executable, so it's actually running against our application. And then we should see that example fail. If it passes, we don't know what's going on because we thought the system didn't do this. So that should be either the system's magically adapted to what we want, or we didn't understand what it did. Or maybe if for some reason you're using some form of AI, it looks at the test and then just finds a way to make it pass. I've seen people try to do that. And then we use TDD to make those examples pass. So we get into that TDD loop and then take each incremental step till we get to the point that this overall behavior of the system passes. Now what this does is, usually when we're working, we've got the developer language over here, which is how the developers talk about things. And then we've got the business owner language over here. And sometimes those things don't overlap very much. I was working at a company in Grand Rapids years ago. Maverick was the one that sent me to Hyundai to look at to set them up to watch the World Cup. And we were working on a video management system for schools. It was my first, I'd done development before, but it was my first really hardcore full-time development job. And the owner of the company was a music major like me, so we had kind of a lot in common. And he was expressing to me how frustrating it was to come and talk to these developers, because he would come in and ask the developers, how are we doing on delivering this project? And he said, they'll start talking about beans and controllers, and I leave and I still have no idea what they said. And that type of experience where he was thinking business owner language, they were thinking developer language, and there wasn't enough overlap for them to even communicate. I finally set them up with some lava lamps that would turn on and off if the tests were passing or not. And then as long as he knew the green lights were on, he was happy. If red lights were on for more than a day or two, he'd start digging in and asking questions. What Gherkin, which is the Cucumber language, lets us do is it lets us get overlap to where we're going to combine. We're going to find a way that we can talk in a way that has enough structure for the developers, for it to be meaningful to the developers, but is in English or French or whatever language you're using, enough that the business owners can understand what's going on. And through this process, we end up with a language that grows in just the way we talk about our application. And I think a lot of times we don't give enough emphasis or recognize how great the value is of just making sure that when people use words, they mean the same thing. It's very easy for people to use words and then mean things completely different. I was on a call the other day with a company, and they're speaking English for my benefit. Most of them speak several other languages, and somebody said, "I demand that you do this." And for me, that word means something very different than it means. It came across to me like, "Oh no," but that's just the way that he's using words, and it wasn't out of. But the point is that those words have a lot of meaning with it. When we use a word, there's a huge abstraction that we're taking along with it that has culture implications and all kinds of things like that. The ubiquitous language that we use to talk about our application grows as we work on developing. So here's an example. When I was in college, in my English class, this is a diagram that I remember seeing in there. Hayakawa, I think it's a linguist and his son. They're both linguists, and they talk a lot about language. And this is one thing that really stuck with me. So in these things we're looking at here, these animals, so there's this land and these animals move in. And there's farmers on the lands. The farmers discovered that the small ones, these ones up here, will actually eat your grain. And then other people discovered that the ones with the curly tail over here, these, will actually bite. So that's no good. Actually, I'm sorry, the ones with curly tail actually eat snakes. So some of the farmers that don't have grain like those because they eat their snakes. The farmers with grain don't like the small ones because they eat their grain. And then the ones with the round head, no matter how big they are, those bite. So the people that are worried about being bitten come up with a name to describe the ones with the round heads. And then the square and curly ones, the ones with the square heads with curly tails, like this over here or this guy up here, those are really good to eat. And I hear they taste like chicken. And the point is if you bring all these people together and ask them to talk about these animals that have moved in, they're not going to have a lot of overlap because their language will have evolved or just developed even just in a few weeks just to be about the things that are important to them. So the person that's worried about the farmer that raises grain is probably going to talk about the way he's going to categorize these things and give names to them is going to be defined by probably whether they eat his grain or not. The one that's trying to eat them is going to be more concerned about whether they taste good, even though that has an overlap in a different dimension across it. And the reason I want to point this out is I like this illustration because it shows how we can be talking about the exact same thing, but depending on our point of view, what part of the system is important to us and where we're coming from, we may come up with a language to describe things that looks completely different. So when you're working with teams and working on developing software, if you're all talking about things differently, it's going to be really hard to get anything done. So here's what Gherkin looks like. You end up with something that looks something like this. You got, given I'm not an admin user, when I log into the system, then I cannot see the admin menu. Now what I want to point out is the structure here is we've got this given, when, and then. So here's the state of the world in which we find ourselves. When I do this, I take this action, then I expect this result. So it's very, very simple, but there's just enough structure here that the developers can actually take this and make it executable against the system. And we could have the inverse. Given I'm an admin user, when I log into the system, then I can see the admin menu. So by using scenarios like that, we end up with this loop, very similar to the test-driven development loop we were talking about, where we write the scenario, we watch it fail, we make that executable, we write the code, and eventually that scenario passes. So here's a brief, let's see if we've got time for it. I have a cartoon about behavior-driven development. I'm going to skip over it. If you're interested, email me and I'll send you a link to it. It's on my YouTube page. But I want to make sure we have time to look over everything else. Okay, so the BDD requirements process. One important thing when you're approaching this is to recognize that behavior-driven development is fundamentally a change to the way you create requirements. And oftentimes we think of it as a way to test our software. And that's true. It's not insignificant. But if we approach it as a way to test our software, we end up doing a lot of things that will keep us from getting the full benefit that we would get if we think of it as a way to create our requirements. Behavior-driven development helps you keep requirements continually fresh. So I've let me give an example. I think I've got to mention this later, but here's an example of an anti-pattern. If I think of this as being just a way to do my tests, I may may be less inclined to get everybody into the room to actually talk through what these things mean. Give me just a second here. I'm going to put everybody on mute just to make sure nothing unexpected happens to anyone. There we go. If I'm thinking of it just being test, I may be more likely to say, oh, we'll just let the developers handle that, instead of seeing it as something that we want to do first to define what the application is going to do. As I mentioned, this runs against the application, so behavior-driven development helps keep requirements continually fresh. Now, you've probably never been in the situation where you had a bunch of requirements that turned out to have nothing to do with what the application does, but many people find themselves in that situation after working on a software project for a number of years, or worse, coming into a software project that's been worked on for the last 20 years, and you look at the requirements and there actually does, and what the requirements when they were written said it does. Okay, so here's how this usually breaks down. You're probably familiar with user stories that are representing the work. So the user story would be something, you might express it as a visitor to the website, as a I'm sorry, I'm losing my train of thought. You've got the standard breakdown of just here's the things that I expect the users to experience. The story just represents the work, but not necessarily an example of it being done. The BDD scenario is created just in time. So we may have a story that represents the work that we use to prioritize and say, is this important enough for us to work on? And we may say no, and it goes back on the backlog. And maybe 2 months later, we ask again, is this important enough for us to work on? Very, very high level, just enough for us to discuss, to know to be able to talk about, is this the next thing we want to work on, even if we don't know the full details of it. The BDD scenario, though, is created just in time, which means you're going to create the BDD scenario right before you actually start your development work. So it's fresh on everybody's mind. What you don't want to do is create BDD scenarios months and months ahead of time and then get to the point you try to work on them and no one having a fresh idea of what was just discussed. So that's an anti-pattern, creating BDD scenarios far ahead of the development work. And this is hard to do because a lot of people will see this as, oh, I just need to get the requirements out. But it's the process that's really valuable of getting everybody that's going to be working on developing it in the room, same time, talking about it, making sure everybody agrees on what it means, making sure we leave out anything that we don't absolutely need, and then starting on the work. And if we do that right before we start on developing the software, we're in a much better place to say, hey, you know that thing we said we were going to do this way? It turns out we can already do it this other way. Is that sufficient? Does that provide us the business value rather than doing all this development work we thought we were going to do? And those types of conversations can happen will happen very often if we do this right before we start doing the work. So BDD, you may hear the concept of the three amigos, but it's not Steve Martin, Chevy Chase, and Martin Short. The three amigos are the developer, the business owner, and the tester. And we think of these in terms of, this is who we want to be gathered around creating behavior-driven development scenarios. And it's not so much that they're individual people, it's more of that we're thinking of, do we have people playing these roles? Or do we have people that are wearing all of these hats? Do we have somebody that's thinking about this from a standpoint of how we're going to build it as a developer? Do we have somebody thinking about it, how we'll approach it, what's the business need for it? And then somebody thinking about how are all the ways that we could possibly break it? Somebody with a tester hat. So the anti-pattern is leaving out one of the hats. Now, notice I didn't say leaving out one of the people. You can definitely do this with just two people. You just need to make sure that you're making a conscious effort to say, I'm now thinking like the business. What is the business value this is going to provide? And now I'm going to switch and think as the tester, how are the ways that I would prove this works? Are there any corner cases that I'm missing? Another piece of the BDD scenario is we don't want to necessarily overvalue the artifact. The artifacts are important, but the thing that's really important is the process that's used to create the software. So the artifact and having our BDD scenarios are very important, but we don't want to get in a situation where we say, I'm just going to create all the artifacts because that's the value. No, the value is actually the process you go through to create the artifacts that makes sure that you understand the system. So let's look at, we look at behavior-driven development, test-driven development. Let's put them together and show you what I kind of alluded to it. So here's our TDD loop, simple test, watch it fail, write code, test passes, refactor. There's our BDD scenario. Very, very similar, but from a scenario standpoint. So if we put these together, we end up with something like this. So we're going to be starting with a scenario. So we're starting with the idea, not of how do I build this in the system, but how would the user actually experience what we're trying to deliver to them. We write a scenario that describes an example of how the user would experience this in the system. Maybe they're able to log on, they're able to reset their password, whatever that looks like. We should then watch it fail. We'll make that code executable so it's running against the system, which will also be failing. And then we come in here and now we get to go down to the lower level and kind of from the bottom up, think in terms of a developer of what's the next function I need? How many functions do I need to get to this point that the scenario finally passes? So that's how those things work together. And this is these two loops together are an extreme productivity boost. And if you've developed your software this way, you're much less likely to have bugs appear. And if a regression appears at some point and you've got all these tests, this is how you built your software, it's usually really, really easy to find what's broken in the system. Because you have one thing that describes, here's how the user will experience this failure that's happened. And you've got another one that says, here's where the developer needs to go to look to figure out why this isn't behaving the way it was before. So on the outside, we've got a BDD scenario loop going around on the outside, and on the inside, we've got test-driven development. Outside, we've got an executable specification, which is our BDD scenarios. Inside, we've got unit and integration tests that are running. So let's talk about what some of these things might happen to look like. So here's a scenario, and we usually want these to be written in ways that, and let me just point out, these two are functionally equivalent. They will do the exact same thing, but one of these reads a lot better than the other. So multiple givens, given one thing, given another thing, given yet another thing. When I open my eyes, then I see something, then I don't see something else. Okay, so just kind of silly stuff made up here, but you could see how this could be tied to things you're experiencing in the application. We can also say it like this: given one thing and another thing and yet another thing. When I open my eyes, then I see something, but I don't see something else. Those key words, you could even replace them with stars. There's not something special about them other than the fact that they give us a way to talk through the example of how it works. And when we take this approach to software development, we make a shift that sometimes software developers have a hard time doing. But in moving from thinking of our software as being something that we're carving out as a chisel, if you ever talk to a software developer and they're like, oh, I don't want to change it, so I did all these hundreds of things, and then you discover that some of the hundreds of things they did aren't exactly what the user needs, or it took a lot longer than you expected. That approach is thinking of dealing with software in terms of a chisel. What we really want to do is think of dealing with our software in terms of a pencil, where you're sketching. You know, the books on how to draw a horse, you draw a circle here, lines between them, and by the time you finish the horse, if you have the patience to do that, which I usually didn't, but by the time you finish it, most of the original lines you've written, you've either covered up or erased, because you're growing toward that rather than it being where you're chiseling it in stone and you can't undo it. Using behavior-driven development and test-driven development can be a very fluid pencil sketching type experience where you're evolving the application step by step through these different stages. Okay, so this is fun and sometimes gross people out, but we're going to do it anyway. So Sphex Wasp, we have Sphex Wasps here in Kansas, I believe. And we're going to take them. What I want to show you here is we can create fairly complicated behavior with very, very simple terms represented in Gherkin. So here's a Sphex Wasp. The way that Sphex Wasps work is they live in the ground. They stock their nest with crickets that are paralyzed so they won't run off. And then when their larvae wake up, the crickets haven't rotted away and they can eat the crickets. So yes, it's gross, but just bear with me. This is kind of interesting. So we're going to describe the behavior of the Sphex Wasp. So this is what it does. Given the wasp is stalking its nest, when a cricket is located, then the cricket is paralyzed, and the cricket is moved toward the nest. Okay, so we've got that. Next scenario. Given the wasp is headed toward the nest, and the wasp is carrying a cricket, when the wasp reaches the nest entrance, then the wasp will drop the cricket, and the wasp will go in and inspect the nest. Given the wasp has inspected the nest, when the wasp exits the nest and finds its cricket at the entrance, then the wasp will retrieve the cricket and store the cricket for its larva. Okay, so we've got these three scenarios that describe how a Sphex Wasp. Programmers did not create Sphex Wasps, so if you don't like wasps, don't blame the programmers. But this describes how they stalk their nest. So we're going to watch a video of a wasp doing this with an added pun completely intended, an added bug in the system. So here is this going on. So notice it's dragging the cricket to the nest. And now the program says, I need to leave it there and go inspect the nest. Here's our bug. Somebody moves the cricket. Wasp comes out. Okay, program says, find a wasp and drag it to the nest. Now the program says go inspect the nest. And then we move it again. Now, the point that this video started being filmed, I think I've got the link to it here, but the guy, I think, said he had already moved the cricket 47 times. So, showed this to my kids, and they started feeling kind of sorry for the wasp, and then they remembered getting stung, and then didn't feel so bad for the wasp anymore. But point I want to show you is these are three scenarios that describe it. There's actually a bug in the scenarios. Maybe this wasp needs another scenario so it's not stuck in this endless loop when we've got a crazy human moving the bugs around. But there's the link for it if you want to check it out. So I showed this to my kids, and they did a little mini retrospective, and they said, oh, okay, the problem is someone keeps moving the cricket. Solution is sting the human. So let's look at some other scenarios. Given it's the first week of school, and this was back in COVID, given it's the first week of school and students are learning from home, when a student logs into the virtual classroom, then an error should be displayed. So that was the scenario many people were experiencing. May not have been what they intended, but it was something that was experienced. Here's a scenario I run on a regular basis. Given I'm going to be on video and my office is a mess when it's 10 minutes before the start time and panic cleaning is initiated, then the mess will be pushed just out of view. I've actually got an old strawberry iMac sitting on the floor over here and other fun things that you don't get to see. And this is a scenario that I would really like to have happen, doesn't seem to be the case, but given I've entered my social security number at the phone prompt, when I finally get to talk to a real person, then they should see my social security number has been verified and not ask me for my social security number again. Given I've entered an invalid social security number, when I finally get to talk to a real person, then they should be required to enter my social security number and then proceed with a support call. This would be an ideal thing for a lot of us calling our banks, and you type in the number and then they seem to have no clue that the number was ever typed in when there's, yes, anyway. Here's a scenario that I've used in a lot. So this was kind of modeled off of something, a project I was working on that needed to validate large numbers of files. So he said, given a valid X file has been submitted, when the process runs, then a file accepted message should be returned. Okay, so on my system, I have a valid X file, and this is set up, like I said, it's executable, so it runs against the application, and it validates that if I run this valid file through, I get file accepted message. But then, so in this particular place, we started, this particular project, we started creating many invalid files. And we're like, we've got all these invalid things that we are, legally required to make sure work correctly, and we'll get the right error message. So we started creating hundreds of invalid files. And after a while, we got to thinking and said, you know what, if the definition of a valid file changes, we're going to pretty soon be needing to change thousands of things that we've made invalid in certain ways to make them match the original specification, which would have been a horrendous job. So this is what we ended up doing. We said, given an otherwise valid X file, so this line knew how to go out and find a valid X file. It said, but the container contains an invalid the header contains an invalid character. We then took that file, made a copy of it, and modified it in this way to have an invalid character. Then we run the process, and the header error should be returned. Now, the beauty of this approach is we were no longer dealing with thousands of different files because we could take a valid file and mess it up in whatever way we said. And as this ubiquitous language for talking about how we wanted to have examples run against the application grew, we developed the ability to make we could mess up files in all kinds of ways and make sure that all the errors came through exactly the way that we expected. And this is, what was interesting about this is this grew to be, it represented a huge amount of complexity in our ability to test different things. There were lots and lots of things that could be tested with this. It was written in a very small amount of code that was written by a guy that didn't know Python just in the evening while his kids were at a water park. And I know that because I was the guy that didn't know Python and put together the stuff that backed this. And it wasn't super complicated to get. It did not take a whole lot of code or a lot of complexity to get something that gave us a huge amount of expressiveness in ways that we wanted to test things. So another example, given an otherwise valid X file, but the first amount field is set to Bilbo Baggins, when the process runs, then an amounts must be numeric error is returned. What was interesting about this particular project is I worked on it for, I think, a few years, and then went on, did some other things. And later I was working with a different team that ended up back on a conference call with this team again. And they were talking about the team that we had done this with. And they were talking about the application, different things. And one area they were having lots of problems with because they would make changes and it would break things in different places. But then I heard one guy speak up. He said, The one place we don't have any trouble with is the place that we've got all these BDD scenarios for, because that's just rock solid. And if anything breaks, we know exactly where the problem is. And it was good to hear that even several years later, they were getting tremendous value out of this. And it was the one part of the application, the part that they had followed this, that we followed this together, was actually the part that they could trust the most to work the way they expected it to. Okay, so let's talk about regression tests, because oftentimes when teams are starting to look at behavior-driven development, the real thing driving it is they want regression tests. Usually they're in a situation where bugs are getting pushed to production, and like, how do we fix this? Let's use behavior-driven development. I think it's important to think of regression tests as being a side effect of behavior-driven development. And the reason is because if we see it just as a way to create the tests, we end up doing things in ways that don't take full, we end up approaching development in a way that doesn't take advantage of the requirements aspect. And this can be a very, very big deal, because I've seen teams that start using BDD, but they're like, yeah, we don't want to use that to talk about how we develop our software. We're going to go ahead and just develop it however we think it should be developed, and then try to use this gherkin language just to test it in the end. And I've seen some teams maybe get some value out of that, but they end up missing the biggest point of it, which is making sure that everybody, business testers and developers, all understand and agree on exactly what the application does. So let's look at a few other examples here, just to kind of get a feel for what behavior-driven development can look like and what some of the scenarios can look like. So this is a follow me robot. I've actually got it somewhere around here. It's not turned on right now, but I'm going to show you the rules for it and then show you them playing out. It's also known as baby duck mode or terrify your kids robot. So here's the rules. Given the legs of a human are identified, when the legs are to the right of center, then rotate to the right. And then kind of the other side of this, saying, given the legs of a human are identified, when the legs are to the left of center, then rotate to the left. Let me pull this out here just so you can see what we're talking about. So this is the actual robot that we're talking about here. So you can see it's kind of a Roomba with a kind of like a Microsoft Kinect on the top of it. So it's a Roomba base. It's not Roomba, it's different, similar robot. There's the brains there, and then there's this sensor thing. So it can kind of get an idea of figure out there's legs in front of it and if they're a little bit to the right or to the left. And then other scenario, given the legs of a human are identified, when the legs are more than 2 feet away, then move 2 inches forward. If they're less than 2 feet away, then move 2 inches back. So here is me terrorizing my son with this program running on that robot.
Okay, slow down. Now walk toward it and see if it will back up.
Now it gets treated.
Okay, come over to me.
Like this backward glance here.
Okay, now run by it really fast, see if you can get out of its range. Good job.
So I feel an important duty as a parent is teaching my kids how to escape from a robot that's following them around, and that may be really useful to them in the coming world that they're going to find themselves in. But the point I wanted to show you is, those were 4 not particularly low-level rules that we went through, and it can make some pretty creepy behavior. My son's now 16, so this was from a very long time ago. He probably would not be scared of the robot now. He'd probably want to help reprogram it. So these rules create something that almost seems sentient. I mean, you can creep people out with this. We've had some friends come over and they're like, their kids were like, I don't want the robot to follow me. So we didn't let the robot follow them, although their dad was threatening it. And we can do these at different levels, right? So we were kind of at a mid-level. This could be a very, very high level of saying something like this: given the legs of a human are identified, when follow me is activated, then follow the human. Well, that would be a very high level, higher than what we did. We were kind of on a more mid-level here, but we could also do it on a really low level, dealing with how the infrared scatter plots show up on the sensors and stuff. That probably wouldn't be quite as useful because it wouldn't have the English language of just people understanding what it means. But my point is that you can do these at different levels, and there can be all kinds of things happening behind doing this that actually of what it's actually trying and testing, or it can be more mid-level like what we were doing here. Now there's example, given it's lunchtime when the speaker keeps talking, then discard 85% of what he says. This is a common thing that I think most of us are programmed to. Okay, so let's talk about the mechanics. So how does this actually work? So we've got three different pieces here. We've got a feature file, which contains the scenarios like what we've been looking at. That's where we put the plain English examples. Then we've got a steps file. Now this is the backing code that links the examples, takes the examples up here and says, okay, how do I actually do these things? I showed this to some people at the Federal Reserve Bank in New York one time, and they got very, very excited because I realized I had not shown them this part, that there's actually work you have to do, and they're like, it just knows what to do. I said, no, I've misled you into thinking this is a whole lot easier than it actually is. It's very easy, works very, very well, but I need to reset your expectations now. And then we've got the program down here, which is what we're actually going to talk to. Now, if you're dealing with a web application, there probably is something in between here. The page object pattern is one thing if you're dealing with this to look into, but basically an API to the web application just to make sure that we've got enough abstraction between the backing code and the program to make it easy to maintain. I'm not going to get into that really detail, but just be aware that can be there. Okay, so let's look at what these look. So here's an example of our feature file. If I'm going to add two positive numbers, so I might say, given I'm on the demo page, when I add the numbers 2 and 3, then the result is 5. I've got another scenario here for it has a negative number and then with two negative numbers. So that could be my addition feature. And when I try to run this, it should fail. And what it should do is say, I don't know how to do this. Cucumber should say, I don't know how to, given I'm on the demo page. How do you, given I'm on the demo page? And so then you'd have to write the code that actually tells it to go to the demo page. And when it fires up Selenium, if you're using Selenium, or you don't have to necessarily be using a UI here. So then you end up with something like this. And if you notice, I've got up here, I just say, given I'm on the demo page, and I'm using a page object pattern here. So I'm saying, get one of the demo pages and call the go method on it, which will move our browser to it. When I add the numbers, now this gets pretty advanced, but I just want you to know that it can be done. If you notice here, this is a pattern matching and this is a pattern matching right here. So what I'm doing is saying, given I add the numbers, or when I add the numbers, I can put any numbers I want in there and not have to create another method to match here. So then those are going to pass to my method, and then I can call my page object pattern that actually passes that into the page and deals with all the HTML and anything it needs to talk to. Same thing down here with the result. I don't have to create a new result for every number I could possibly see. So this doesn't take much code to back the English examples over there. And if I'm careful how I do it, I could have these matching patterns like I did with saying the thing I showed earlier where we were saying, given I'm on the header, the system behind the scenes would look at that header as being something it would match on, figure out where the header is and figure out what it needed to change just based on the fact that, so the overall structure was the overall steps file was very small because it would match and then look things up to figure out where it needed to go into the file to stick Bilbo Baggins in a number field. So these are how the things match up. So given I'm on the demo page is matching to this. When I add the numbers, is matching to this. And then the result is matching down there. And this, like I said, I don't want to get into too much detail on this. This is what the page object thing is pattern is actually doing behind the page. I don't have the one to actually retrieve the number. But when we say go, it's going to go here and go to that web page. And this could do all kinds of other things. And then when we say add the numbers, it's actually going to go to the driver. So it's going to grab your web browser and send the keys that you gave to it to the ID of the first number and then the second number, and then it's going to click on the button. And if that just looks way too technical, just know that it's possible to control a browser through this so it can actually click through like a human would. So let's look at some examples and see some of the other. What I want you to take away from this section is just that there is a wide variety of expressiveness that you can use to represent examples of what you want the system to do. So Arabic to Roman number conversion. So Arabic numbers is going to be what we're used to dealing with, 1, 2, 3, 4, 5, base 10 numbers. Roman numerals you're familiar with from clocks and probably having to do stuff with it in school. So simple number converted to Roman numeral. So given I'm on the demo page, when I convert the Arabic number 1, then the Roman numeral displayed is I. I've got another one saying, when convert 14, then it gives me this. So I can have something simple like this. And I may have my backing code that actually deals with this. This is very similar to what we just did. Notice we match here. I don't have to create a new line for every single number I want to check, or everyone I want to display. So fairly simple. But we can also do some other things like this. So this works just fine. But what if I'm wanting to test 99 or 100 or 500 Roman numerals? This might get kind of long, and it's not really easy just to look at and say, oh, this, I know this is this. That would be represented more as a table. Well, we're in luck, because we can also do something like this. If you are familiar, if you're as old as me and familiar with the term mail merge, this is basically doing a mail merge. I mentioned that to a bunch of much younger developers the other day, and they're like, what is a mail merge? It's like, okay, I need to come up with another way, a template. Maybe that's a better way of saying it. But what we've done here is we've created our scenario outline, and then we've said, go through, here's all the data we want to put in here, and go through it and fill out these forms and just run it each time. This is, oh, so this is hard to do with Salesforce. Okay. Interesting. So what we're doing here is we're going through here, we're saying, given I convert the Arabic number 1, then I want to, the Roman numeral displayed is I. And I can build this out as much as I want to. And this is probably going to be a lot easier for me to just look at really quickly and scan through and see what I expect to do, instead of having to read this every single time. This could get really, really long and have lots of things. It's also really easy just to add something to this instead of copying and pasting this and then changing stuff. One of the most interesting and effective uses I've seen of this type of thing was dealing with permissions. So in this particular case, so say we're given a, let's say this is some type of publishing system, and you have to have permission to move things between different statuses. So given we've got a document in approval pending, when the admin user tries to view it, then the result should be it's allowed. But if an editor takes an approval pending and tries to approve it, then that's blocked in this particular case. Evidently, we don't trust our editors very much in this particular case. But the point is, this can be built out to give you a very robust way of being able to say, what does the system do? And you go look and say, oh, okay, I see what it does. And I know this is actually executed against the system. So not only is this what I'm saying I want it to do, I know this is what I'm proving it does. I was working on a system with the government system, and we did this for every single page in the application. And whenever you added a new role, you went through and just added for that role for every page. And it wasn't like there were thousands of pages in the application. But we were able to test, if somebody had this role and tried to go to this page, do we expect them to be able to get to it? If they tried to go to this page, do we expect them to get to it? And it gave us a huge amount of confidence in our security, because nothing could slip through, right? Every time we built our application, we tested that every single way that you could get to the application was only allowed to do the things that were specified in our list here. And if we ever had a question about why someone couldn't do something, we could go to our list and say, no, our requirements say that they can't do that. Now, we can change it if you want to, but this is behaving the way it's expecting because we test this every single time we make a change. And then the other thing I wanted to point out is you can also have this idea of a background, which if you have a bunch of setup stuff that has to happen every time you run a scenario, you can put that under a background heading, and then you don't have to have it cluttering everything up. So I've seen situations where people had like 5 or 6 steps that needed to happen at the beginning before they did all their scenarios. And they could put those all up there, so it was very, very clear exactly what was happening. There was no confusion about what was going to occur before each scenario. So it wasn't hidden behind just an abstraction. You could see it, but then when you could point, it helped you look at the scenarios and know what's important about these that's different from scenario to scenario. And in this case, we're also combining that with a scenario outline. So there's lots of expressibility. There's lots of ability to express what you want the application to do here. And this is something that for many teams, what I found is when we've got the name of the feature at the top, it's very convenient to put the user story right after that. If I put the user story right after that, then everybody, as we're writing these things together, everybody's on exactly the same page of what we're trying to accomplish. Because that's just text. It doesn't do anything. It's just there and can remind us of what were we trying to do when we created this feature. Okay, so the different levels of things we talked about are user story, like I just showed you at the top, Cucumber scenario, Cucumber feature file. So a user story would look something like this. As a user, I want to convert Roman numbers to Roman numerals, so I don't have to do it in my head. You like that so there, so I don't have to do it in my head. Okay, and then we might have our cucumber scenarios that take that story and say, okay, how am I going to actually give examples of what that means? And this is really key. So if we've got this user story and we've been trying to decide when we're next going to work on this, and it finally makes it to the top of our priority, we're going to work on it in this sprint. We take that story and then we get together the developer that's going to work on it, somebody from business that understands why we're doing it, why it's important, and somebody that's wearing a testing hat that's going to help, that's really going to be responsible for making sure that we don't miss any edge case in what we're trying to build here. Then we sit down and we write this together. And it looks really simple and everything, but this isn't just one person writing stuff down. This is a lot of conversation back and forth about what do these things mean. Do we want to use the term Arabic number? Would it be better to refer to it as base 10 number? Who's going to be reading this in the future? Are they going to understand what this means? And we go through till you're happy with the language. And this is where it becomes almost more of a linguistic thing of how do we actually express in a way that we all agree what this is going to do. So we go through and we create that together. So we've got the user story that's a high-level representation of the overall goal. And then the cucumber scenario, the specific example of an aspect of a feature. And the beauty of this is when the developers start actually trying to do development work, there are far fewer just, I don't know what we need to do here. A lot of the things that, as a developer, it's easy to get into development and if you don't have a business person in the room, you've got to make lots of decisions based on your best guess that often proves to be wrong. Or you have to go find the business owner. This front loads a lot of that. So a lot of those things, those ambiguities are worked out through the process of just trying to figure out how do I articulate what this needs to do. And you can work through those things together. And then, I mean, ideally having the business owner available for the developers is good, but you end up with far fewer things where the developers head down one trail and then decide it's not what's actually beneficial for the business and stuff. So this is very, very key talking through that. So we have a cucumber feature, which is like one of these files. So it's a collection of example scenarios that complete a feature. And let's see. So at this point, sometimes I have people sit down and actually write scenarios. We're not going to do that now. If you want me to come in and do this with your team, this is where we'd actually do some hands-on stuff. I also do this with a bunch of little robots that I don't have to show you, where we actually go through and look at what PPP looks like from programming robots. They're starting to get a little old and their batteries aren't quite as long, but it worked last time my son and I did it for a group. But I want to show you one other thing here, just for fun. So this is Robot Sumo. So here we've got robots, 2 robots in a ring. Only one will remain in the ring. Doesn't sound quite as exciting when you say it like that. But let's look at a user story. User story might be, as a sumo robot, I want to push other robots out of the ring, so I will win the match. Okay, so it's a user story. It's written from the standpoint of a robot. We're kind of personifying the robot. Usually you want to be the users. Maybe it should be the person that owns the robot that's going to win a lot of money, but we'll let it slide this time. And then we'll have a feature file that maybe looks like this. It says first scenario, no robot identified. Given sumo mode is activated. When the front sensor does not detect a robot, then turn slowly in a circle. And scenario robot identified. Given the sumo mode is activated, when the front sensor detects a robot, then move forward. Okay, so I will tell you that the video we're going to watch, they are much, much more complicated than this scenario. But just think about how implementing these examples could actually produce something somewhat like what we're going to see here in just a second. Now, if you notice that guy over there standing up there, look at all the protective gear he is wearing. I mean, he's wearing, I don't know what that is, but it's designed to protect him, and there's why. Anyway, I ran across this video and realized that some robots are a lot more exciting to watch than maybe mine just chasing my son around. And I like the guy with the flag. He's kind of like a matador trying to do it. So these are evidently can be kind of dangerous matches. Anyway, last thing I want to talk about is how much does behavior-driven development cost? Well, you don't have to buy anything for it. Somebody's probably willing to sell you something, but Cucumber is something that exists in a number of different languages, and it's not something that you have to go out and buy. And what I'd like you to think, another thing I'd like you to think about is how would this change the role of the people that do your testing? What I found with teams that take this type of approach is the first thing that happens is testers are like, this is never going to replace what I do because what I do is far too valuable. And I found it's not a good thing to disagree with your testers. So say you may be absolutely right. But what we really want you to do is start giving the team feedback on the things that they let that slip through with this process. So keep testing however you feel it needs to be tested, but let's bring your expertise to the very beginning. Let's bring your expertise to the very beginning so we can talk with the developers about what good quality would look like before they write the code, instead of asking them to try to retrofit it later with the stuff that you could have told them ahead of time, but they didn't ask, and so they didn't know, and then they made things in a way that wasn't any good, and then they had to go back and try to mangle it to work in a way, and now they've got code that they're not happy with continuing to maintain because it's not what they would have written had they started that way. You get the idea. This is what I found when you do that with testers is they really like being involved in the beginning and getting to prove. And, at first they're like, "Oh, I always have to test at the end." Yes, yeah. Taylor, like Taylor said, is just the testing to the left, so you get way more valuable out of the testers of them telling you what to think about ahead of time instead of telling you the things that you should have thought about but you didn't. What I've done, and the way we've handled this transition on some teams, because the testers are very reluctant to let go of their manual testing, is we say, okay, start documenting anything that we let get through that you find. Because what we want you to do is, instead of thinking about so much about that you're improving the quality of the code, we want you to kind of go up a level and think about you're helping improve the quality. The stuff you're finding at the end, we want to feed back into improving the quality of the team that is producing the code, so there's fewer things that get through. We want to improve the process, not just the product that comes out the other side. And if you have those conversations, it usually can get them thinking like, okay, that they having dealt with all the things that testers have dealt with that have slipped through, they can usually see the value of that. And then oftentimes what happens is they get to the point that they realize that they're not finding anything anymore because they're doing a good job of raising things at the beginning. And they also start being able to trust that all the tests are working correctly, which doesn't mean they never go in and try something out. But they're not necessarily spending hours and hours and hours just testing stuff that they know the system actually checks for. A government project I was working on had to do a full manual test, and that's how they tested stuff. It took, I got the numbers, it was either 6 people, 12 weeks, or 12 people, 6 weeks. I guess man hours, people hours, that works out to about the same thing either way. But that's the level of testing it took just to get through the stuff they had written down that they needed to test. And still lots of things got through. So when we were working on rewriting that system, the testers were understandably dubious that we were going to be able to replicate that same level. But over a few years of taking this approach to writing our software, we were able to get to the point that we could test better than they could do in that 12 weeks. We could test in about 2 hours, the entire system, all the things that they would have done as individuals. And then the testers were doing 2 things differently. One, they were now participating at the very beginning of things and bringing their expertise to the development process and to the planning process. And they were having more time afterwards to go in and say, okay, I know this met all of our examples, but let me go in and think like a human. Is there anything I might do that would make this hard to understand? Is there, like maybe these buttons do exactly what we said they're going to do, but are they so close together I might actually slip and poke the wrong one? Which I don't know if you remember here. I was going to say recently, it's probably been 5 or 6 years now, but in Hawaii, they accidentally sent out a text message to everyone, basically saying that they're under nuclear attack and everybody's going to die. That there wasn't much, take shelter, but we're under nuclear attack. Which taking shelter, yeah. Anyway, they sent out a message that may have even caused some heart attacks. What happened in that scenario is they had a system that worked just fine. There was nothing wrong with the system, but there were 2 buttons, and one button said, "Tell everybody we're testing the system," and the other said, "Tell everybody they're under nuclear attack," and that it's not a drill. Somehow they clicked the wrong button. BDD scenarios are not going to catch that, but a tester going in and just looking at the system may go, you know what, we probably don't want these buttons as close together, or maybe we want a "are you sure you want to scare everybody" button that comes up at the set. Those are things that testers are still going to bring value to, but oftentimes they don't have time to go through and think about those things because they're so busy logging in and out as every single person that could, or every single type of user and testing every single page and those types of very, very mundane, life-sucking activities that aren't very interesting to do and can easily be automated. And that's where the BDD scenarios, having those around where you can continue to run them, can be very, very valuable. So that covers a overall view of behavior-driven development. There's lots and lots of details. This is the type of thing that I often go in and help teams with, particularly if you're in a place where you're starting to on a new project or a new piece of a project and this looks interesting. Reach out. I'd love to talk to you about it. If best case, we could work together, but even worst case is still a good case, which is we can talk through it and maybe I can point you to some things that might give you some ways to get started and an idea of where to invest time, how you might be able to use some of this stuff, even if it's not me working directly with you. So I'm going to stop the streaming there.